In this video, we're going to take a look at the water quality of the Nooksack River to see if it's healthy for our salmon. Specifically, we're going to be looking into the temperature, we're going to be looking at the turbidity, and we're going to be checking out how much dissolved oxygen is in our water. Now, we already know salmon need cold, clean, and clear water, but why do salmon need cold water to survive? Salmon are really happy in water somewhere between 5 and 20 degrees Celsius. That's also about 40 to about 70 degrees Fahrenheit, but they like water much colder than we would enjoy swimming in. They need that cold water so that their eggs can grow, so that their fry can develop properly. If the water's too hot, they're not going to be able to move around very easily. Same if it's too cold, they're not going to be able to move around very easily. So we want to make sure the Nooksack River is cold enough for our salmon. So the first thing we're going to test is that temperature. How cold is our water? The easiest way to test this is just to use a standard thermometer. Earlier, we took this sample straight from the Nooksack River and we put these thermometers in so they could get used to the water for a little while. If we pull one out, you can see that blue line. It goes up just about 20, maybe a little beneath 20. So it's about 20 degrees Celsius. Why don't we check the other one too? It's nice to have two just to make sure both of them are working properly and that our data is accurate. So this one it's a little bit beneath 20 as well. So salmon are happy in water anywhere beneath 20 degrees Celsius. Now looking at our chart, that's not in the blue zone, it's actually in the gray zone, which means that this water might be a little too warm for our salmon. So out of excellent, fair, and poor, we would say that the temperature is just fair for our salmon. Let's move on to dissolved oxygen. Now this is going to be the biggest experiment we're doing here. We're going to be using some pretty cool chemicals. That's why I've got my goggles and why I've got my gloves on to be safe. We want to measure how much oxygen is in the water. Now, you know, in some of our other videos, we've talked about how cold water actually holds more oxygen. Now we know that the temperature is only fair, so we want to see if there's enough oxygen in the water for our salmon based on that temperature. To do that, we're going to do a series of chemical reactions. When we measure oxygen, we measure it in something called parts per million. Now this is really easy to visualize if you visualize it like a fraction. There's oxygen dissolved in the water that we can't see. But how much oxygen is in the total water? So if you look at it as a fraction with oxygen on top and water at the bottom, we want to know how many parts of oxygen are in 1 million parts water. If you look at this chart, you can see the blue zone is anywhere around 10 and above. If we find that we only have 6 parts per million oxygen, that's going to be a problem for our salmon. So the first thing we had to do was get a sample from the Nooksack River. Now we want to know how much oxygen is in this, but we can't see it. So we need to make it so we can visually see our oxygen so we can start counting it. Now to do this, I'm going to add our first chemical. We call this chemical 1, but it's actually manganese sulfate. This is going to clean our sample. Sulfates are used in lots of soaps that you see in your homes. Stuff like laundry detergent has lots of sulfates. So we know that by putting a sulfate in our solution, we're going to clean our sample so nothing messes with our results. Okay. We're also going to add our second chemical. This is chemical number 2. It's also called lithium hydroxide monohydrate. Now this is going to change the color of our sample. So we're going to start to see the oxygen come through. So take a guess at what color you think it's going to become. All right. Woo, we're going to mix this up. Take a look at what it looks like inside the sample right now. Can you see anything forming in the sample? Some students say it looks a bit like orange juice, like an orange juice pulp. That's actually our oxygen. So our chemicals have grabbed hold of our oxygen so we can now visually see it in our sample. And it looks like quite a lot, but we know it's going to be a small number out of 1 million. I'm going to let this sit for a while. It's got a few more things to do before we can move forward. So we've already tested how cold it is. We're taking a moment to test how much dissolved oxygen is in it. But now we want to know how clear it is. Now the way we measure clarity is through something called turbidity. That's just a measure of how much stuff is in the water, how much dirt, how many particles are in the water that's making it hard for us to see through it. So here we have some samples of different turbid environments. Now salmon really love clear water, almost as clear as tap water, as I'm sure we all would. So here we have a sample from a low turbidity environment. It's just enough dirt that it looks like it could be from a real river, but the salmon can easily see where they're going. They can easily avoid predators and catch prey in water like this. A medium turbidity environment would look more like this sample. There's some more gunk in the water, more stuff, more dirt, more sediment. And it's a little harder for salmon to see in a river that looks like this. But how about an extreme example? How about a really high turbidity environment? So in this sample, I don't know if you can see through it at all. I certainly can't. This is a good example of what a river might look like after a really big series of storms, where there's lots of runoff, lots of extra rainwater flowing into the river, lots of high flows and high flood warnings. The river can get really churned up and muddy. But this makes it really hard for our salmon to breathe. Those particles can clog their gills. It can also make it hard for them to avoid predators, to find each other, to get where they need to go. All around, not ideal for our salmon. But we want to know how turbid the Nooksack River is, and we hope it's low. To do this, I've actually brought a turbidity tube with me. At the bottom of this tube is a symbol called a sucky disc. The way we use this is we look through the tube to see if we can see that sucky disc symbol. It's black and white. If we can't see it, we're going to pour out some water until we can see it, and that's going to give us our turbidity measurement. So currently our tube is all the way full. Now if this was a low turbidity environment, we would be able to see the sucky disc all the way at the bottom, that black and white symbol. I don't know about you, but I can't see it. So we're going to pour out some water. So I poured out quite a bit of water until I could see it at the bottom. So why don't we take a look now, and you'll see through the water, we can finally see the sucky disc. So that tells us that our environment, it isn't low turbidity, because we had to pour out quite a bit of water. But it doesn't look like these environments either. Now if we look at the side, we'll have our depth and then our turbidity measurements. And this looks like it's somewhere between 15 and 20, maybe around 18. So we found that our turbidity was around 18. And on our chart, that's still in our excellent zone. So our clarity is still excellent habitat for our salmon. All right, now that we're done with temperature and turbidity, let's go back to our dissolved oxygen experiment. Now our sample's been sitting for a little while, and it looks a bit different than it did before, right? All of our solids have settled to the bottom. So all of that pulp-like material that's grabbed hold of our oxygen, it's all settled to the bottom now. You can actually see it in there, kind of moving around. Now we can see our oxygen, but we still can't measure it. It's not in a form that we can measure yet. So to do that, we're going to add our third chemical. This is sulfamic acid. Look at this. Yeah. Sulfamic acid is once again going to change the appearance of our sample. How do you think it might change the appearance of it? This is going to make it so we can count our oxygen. Get in here. Really gritty. Okay, going to mix it up again. So it looks a bit different. It went from looking like orange juice to looking a bit like apple juice. All of those solids that were in the water, they've redissolved in and you can't see them anymore. But actually that's made it so we can easily measure our sample. So we're at one of the final steps. Now we're going to measure out 1 million parts water. And it actually fits in this little tube. So let's pour out our sample to 1 million parts water. And we're going to just transfer it into this container. Right. Still looks pretty yellow. And I know they look like they might be different colors, but that's just because this one's shallower. They're actually the exact same color. Now the final thing we want to do is count how much dissolved oxygen is in our sample. And we have a really easy way to do it. We can actually count it drop by drop. So I'm going to add our final chemical, sodium thiosulfate. Now as I put it in 1 drop at a time, each drop is going to represent 1 part per million oxygen. And the water is slowly going to become clear again. It's going to look like drinking water. Once it is perfectly clear, we have measured all the dissolved oxygen possible in the sample. So we want to keep track of how many drops it takes. 2, 3, did I get one in there? I can't see it. 4, 5, oops, 6, 7, 8,
That was 9.
9, 10. So we're at 10 and it's fairly clear, but not quite yet. Okay, we're at 12, 13. Ooh, that's looking pretty clear. Let's put one more in and see if it changes. 13. That looks like drinking water. That looks pretty clear to me. So that was about 13 to 14 parts per million oxygen. So let's take a look at our chart again. So we had about 13, 14. That's actually in our blue zone. That's in our excellent zone for our salmon. So our salmon should have plenty of oxygen to be thriving in the Nooksack River. So over the course of this video, we looked at how cold the water is, we looked at how much oxygen was in it, and we looked at how clear it was. So take a moment to come to a conclusion for yourself on the overall water quality of the Nooksack River. Is it excellent for our salmon? Is it fair for our salmon? Or is it poor for our salmon?